How many have sat through one of my presentations before? Okay, you're going to see some of the same stuff because it still applies. And glad to see some of the folks that got stuck on H1 have gotten here. So we know the road's open, so be prepared for people to wander in as we go. As Marlena said, I'm Claudia Akroyd. In case you don't recognize me without the hard hat and the vest. And I'm going to talk first off about inspections. What is an independent inspector? It's someone who's independent of the day-to-day workings of a project. That's why occasionally when somebody calls me and says, can you look at my SWIP, or would you like to come to the pre-construction meeting? I say no. I can't get involved in SWIP or amendment preparation. Basically, it's up to DOT to approve those. I come to inspect projects at least once a month. Now, there is criteria for reduced inspection, but I got to tell you, there are some projects that may never go to quarterly inspection. These either because they're too large or too complex, or it might be, for example, we're going to have a bridge replacement project where they're actually working in the water. That will probably never go to quarterly because there's too many chances for an error, and I'd rather catch something before it becomes a major issue. These are the criteria for reducing inspection frequency. No major, no critical, no more than 3 minors, not more than 3 minors in any 1 month, and no more than 6 total within a 3-month period. I.e., if you get 2 minors each inspection for 3 months, it will not go to quarterly. These are the types of deficiencies, the definitions of them. When we find a critical deficiency, that has to be corrected that same day. It also sets off quite a few bells and whistles, and everybody gets involved. Major and minor both have to be corrected within 5 calendar, not business, calendar days. So I don't have the luxury of not inspecting projects before holidays. What I try to do is inspect one where there won't be a lot of stuff I find. Some majors can be downgraded to minor if they're corrected before I leave the site. It will still show up as a deficiency, but it'll show up that it's been corrected during that day. A good example of that is you have the junior laborer fueling the Bobcat. He doesn't put down the protection that's required when you're fueling a piece of equipment. He starts talking story, and he overfills, and you end up with this huge puddle. If it's a large puddle, it could be a major, but if it's corrected before I leave the site, it will be downgraded to a minor. Some general facts. You have to install the BMPs per the SWIP prior to construction starting. That doesn't mean you're starting to grub and clear when you're still installing BMPs. That means they have to be all in place before any element of work starts. You also only limited to what is needed to install the BMP. By that is you're putting a silt fence 30 feet from the sidewalk. You don't clear from the sidewalk to where you're installing that silt fence. You only clear what you need to install the silt fence. DOT must inspect all the BMPs prior to allowing the contractor to work. Contractors, if you're ready to start, go grab the DOT inspector and say, have you done the inspection? Can I start? Now in the CPMS, that's listed as the Pre-construction verification inspection, or what I commonly refer to as the initial inspection. If you're going to phase BMPs, it must be lined out in the SWIP. If you're paving a 5-mile road, you either have to put everything in at the start before you start paving, or you phase it. And it doesn't matter whether you do it by block, by mile. Somehow it needs to be delineated in the SWIP how you're going to phase those BMPs. When GP did Kalanianiole Highway, they didn't use block. They had specific areas that they lined out in their schedule, and they said, we're going to install the BMPs 100 feet before the paving limits and after, or so many drains beyond. And they just marched down the road. The same is true about removal, and I'll get to that in just a sec. BMPs must be installed per manufacturer's specs. And I'll show you some examples. You need to send the installation instructions to the field with the guys that are doing the installation. Best place to put it is in the SWIP, because you're required to have the SWIP on site. Also read the fine print. Don't just look at the pictures, because there's some little comments in some of those installation instructions that if you don't catch them, it'll screw you up. Per DOH, you can use any available BMP provided it's appropriate to the situation and is installed per manufacturer's specs. And a little later, I'll show you some places where they have done that, but it's not the best use of the product and may cause them problems. You need to provide a layered effect. And I'm going to harp on this a little bit later, but inlet protection cannot be the only line of defense. It's the last line. You have to layer your BMPs. Talking about addition or removal BMPs. If you have a project and it starts raining and you notice you need some additional protection someplace to keep the project in compliance, add it. Worry about the amendment later. Keep the project in compliance. Now, if you want to make an elective change, say whoever wrote your SWIP says you're only going to use silt fence, that's the only thing you can use. If you put into the SWIP at the start, we're going to use silt fence, biosocks, filtrate, sill socks, snake bags. You have that variety to choose from. Before you can make that change, you have to have an approved by DOT amendment in place prior to making that change. You make the change and I come out and say, well, we submitted it, but it's not approved yet. It's still a deficiency because it has not been approved prior to doing it. You want to remove a BMP. If it's in your SWIP that you have criteria for removal, there's still one additional check. DOT needs to approve that removal. Think about it this way. DOT owns the project. They are the approving authority. Already mentioned building and flexibility. Now, when I go out to an inspection, these are some of the steps I go through. I read the SWIP, I read the permits, especially the 401 and 404. If you've ever worked a project with those, they contain some very specific instructions that are peculiar to that particular project. We had a case where we had two bridge projects a couple miles apart. One of them said that they had to put the turbidity barriers in at the start of construction and remain throughout the project. Just down the road, and this is Kahana and this is Punalu'u. At Kahana, they only put them in at a certain point in the construction. Another project, Iea Stream, it was in the 404 that the BMPs needed to go in a particular order sequence. So you need to read those documents. When I go out, I will meet with DOT project staff to discuss the SWIP, any questions I have. It's up to DOT if they want the contractor to join the inspection. Frankly, from my standpoint, it's welcomed, but that's a DOT call since I'm technically inspecting DOT's inspection process. I will look at some of the on-site documents, like the inspection reports. If it's a first inspection, I will ask to see the pre-construction verification report. I will walk the site, look at the BOP placement, the topography with DOT and the project, the contractor staff, if available. I take pictures of both good and bad. I'll brief the project staff on completion, then go back and write the report. And then I will transmit that to DOT. Now, I try to get the inspection report back to DOT either that day or at latest the next day, because the 5 calendar days starts with notification of a deficiency, which is the day of the inspection. These are some of the areas requiring inspection. Basically, any disturbed areas, stormwater controls that are supposed to be in by permit. Look at primarily topography. This isn't rocket science. You look at a piece of land, you see it slopes this way, water's going to go that way. I'll follow where that's going to go. I will try to look at all the discharge points. Now, discharge points, if you have a permanent project, is very important you inspect each and every inspection. There was a case, it was a city project, but there was a case where DOH went out and did a compliance inspection or a compliance visit, and they were cited for 2 things. Their weekly reports were not 7 calendar days apart. If you look at a lot of the documents, it says weekly. If you look at Appendix C, it says 7 calendar days. They cited them because one was 9 and one was 11 days apart. They also cited them for not inspecting the discharge points every time they did an inspection. It's not just when it's raining. Now, occasionally, I normally pre-schedule my inspections with the engineer. It comes that day and it's pouring rain. I will still come. One, I don't have the luxury a lot of times to switch the inspection date because the months are usually pretty tight, and it's a jigsaw puzzle trying to get all the projects in. Second, when it's raining, it's the best time to do the inspection. Now, if something's impacted by the rain, normally I will put it in as an action required. However, if something has failed, not because of the rain, but it's a problem with the installation, that might get cited. This is a definition of disturbed area by DOH in Appendix C. Notice headquarters, parking areas, all that's part of the disturbed area. You should have, if you're on a project, you should have an inspection strategy. Most companies that have a strong safety program, you probably have an inspection strategy in case OSHA shows up. You should have the same thing for when any inspector comes out to look at your site. You need to, first of all, be upbeat. How many of you have gone to look at a project, you've gone in, you start talking to somebody and they're like, oh crap, they're here again, and start rolling their eyes? It kind of puts an inspector off. I will look at the documentation of the inspection and take pictures. If it's DOH out there and they say this is wrong, my suggestion is you don't argue with them. Chances are you're going to lose that. If I tell you that something is not quite right, I will entertain a discussion about that issue. There might be a very valid reason why that's not there, but in the final outcome, need to take it to heart. If you have a problem with a particular type of situation, talk to whoever's doing the inspection. They might have an idea how to fix it because they've seen a lot of different projects. Be upfront and honest. After you've done this for a while, you can tell when the sill fence just got knocked down by the truck versus it's been down for 3 days because it's dirty. Don't make excuses. BMP maintenance is a daily function. It's not a weekly or after an inspection function. You should correct things as soon as possible. Remember I said take pictures of the good and bad, whatever the inspector is taking pictures of. When you correct something, take a picture that day. Best thing to do is take a picture with a date timestamp on it. I mentioned that I try to get the inspection report back to DOT that day or the next day at the latest. There is a delay in getting anything back from DOH. Remember, they have very limited staff, and they not only have DOT, they have city, they have harbors, they have airports. So there's always delay. You want to be able to go back to your inspection notes, find out what they're citing you for, and say, oh yeah, we fixed that the next day, and pull out the picture and send it back with the documentation. Also, don't tell them what you think they want to hear. Sometimes that will get you into trouble. Where do I find information on BMPs? Most of this is the same as we've had before. We have the state manual. If the website where you can download it, it's on your handout. There's also a lot of other good information there, like permanent BMP guide, Swift Plan Review Guide, links to EPA, that sort of thing. My advice to you is have a copy of that on your site. EPA Menu of BMPs. I put a very generic website on here because right now EPA is modifying a lot of their sheets. So there's minimal BMPs on their site right now. There's a new, now the picture got cut off here, but this is a U.S. Department of Transportation Federal Highways Administration Guide. And it's actually a handy little guide. It shows you what's good, what's bad. It shows you pictures of something not installed right and pictures of something that is installed right. And you can download that also for free. This is what is driving the train. HAR 1155. For permitted projects, it's Appendix C. Most of your SWIPs, the template for the SWIP, is also based off of this. There are also 2 other appendices that if you're doing dewatering, for hydro testing or just general dewatering, you should be aware of. Look at the manufacturer's websites for BMPs. Read the installation instructions. Read the fine print. Send these to the field. If you just give the guys the BMPs and tell them to go out, and all they have is a picture, more often than not, it gets installed wrong. Remember, you need a layered approach. Inlet protection is the last line of defense, not the only line. Remember, in a lot of storms, we pull inlet protection because it's the worst scenario is the area floods. Here's a very simplistic example. On the left, you have a disturbed area right next to a sidewalk. Now, the landscaper did a good job. It's nice and level with the sidewalk. However, in a heavy rain, it's going to run dirt over the sidewalk and into the gutter. From the gutter, it goes to the inlet. Now, the inlet protection has been pulled. You have just discharged construction water into the stormwater system. On the right, they added biosocks or filter socks to the edge to hold that. I keep saying inlet protection is the last line. Protection requires a layered approach. Now, granted, some of the storms we have here, a lot of the BMPs will fail at some point under a really heavy rain. I've got the definition of critical back up here. Notice the last portion, generated by construction activities. Basically, the only thing that's supposed to go into these inlets is rainwater. Not the potable water from your water truck or the potable water you put in your cold planer. That'll get you in trouble. That's considered construction water regardless of the purity of the water. Here are 3 examples of critical deficiencies that we pulled. I have 3 rules of inspection. If something's going to fail, it's going to fail just before I get there. If somebody's going to do something stupid, they're going to do it in front of me. And the third one that I just added, life is not fair. Sometimes it really sucks. These are examples of failing just before I get there. In the one on the left, they have pulled out part of the gutter, taken it down the base course. As I'm pulling into the staging area to meet up with the inspection team, it poured like a son of a gun for 15, 20 minutes. Before that, it had been bone dry. It was dry for the rest of the day. Notice the puddle up, is that, in the top circle. I'll forget the pointer. It overflowed, came down to this inlet where there's no protection. Obviously, that is a critical deficiency. The next 2 are water from construction activity. The one in the middle, the water is coming in from the site. What happened here was they overfilled a cold planer. It ran off the drip protection, picking up a little oil sheen, ran down the curb and into the inlet. Inlet protection is in, albeit the snake bag was broken, but that was deemed critical. Construction water entering the stormwater system. The one on the right, again, was a cold planing accident. They had gouged out an area by standing in place for a long period of time. Water had accumulated as a large puddle. It overflowed, ran down the gutter, and the inlet protection was in place. It was pushed back in, but it was in place. Now, looking at this thing, the water's coming down the gutter. There's water ponded in front of the inlet, but it's not raising as the water's coming in. It's going somewhere. It went into the inlet. You'll see this slide again, but the primary reason why this is in here is this is actually a crop picture from the insert from the SWIP. And on the right, I highlighted a couple things that are actually in the instructions. Designed to reduce. Designed to mitigate. It does not say eliminate or prevent. You still have to prevent that sediment-laden runoff from reaching the drain. I'm going to talk a little bit about inlet protection. Okay, you saw this one before, 3 types of inlets. One, the GDI, it has a frame all the way around it. That's pretty easy because you have that friction to hold anything you put underneath it. The one in the middle does not have the frame all the way around it, so roadside and curbside, you're going to have to do a little more work to keep the inlet protection in place. On the right, some of the ones on our highway also have what looks like a catch basin attached to the GDI. So you got to worry about protection of both. These are some of the typical inlet protections or GDIs systems that we've seen used here on Hawaii. This is not an endorsement, it's just a listing of what's commonly being used and some advantages and disadvantages of it. Ultra drain guard, witches hats. These are good for high flow areas because the water is forced through gravity and pressure through the fabric. There are cutouts in the top for overflow. These were used extensively on H1 rehab along the median. If you block drains on a highway like H1 with just fabric, the road's going to flood. They are difficult to clean because you got this heavy bag and you got to pull the inlet, got a couple guys to hold on to the bag. Both these areas were in high flow rate. The one on the left was quickly clogged with just fabric under the grate. If you're using just filter socks or snake bags with no fabric under the grate, you've got to be particularly vigilant because if they break, there's nothing to prevent the stuff from dropping into the inlet. Also, if you're paving, because of the nature of the paver, as you go next to these GDIs, you always get asphalt into the protection or cold planing material. That needs to be cleaned that day. It does not filter. This is one of the examples that is a continual problem. This GDI is in the roadway. So as the cars rumble over it, they abrade the fabric, and it tends to drop in. We haven't solved this one yet, other than the contractor changing it more frequently. If anybody's got a suggestion, please pass it along. Catch basin types. You got the smooth and you got the directional channels. Again, some examples of protection we use, advantages, disadvantages of both. If you're using a filter sock or snake bags and you're putting something behind it to keep it from falling in, make sure you bring the protection all the way around the end. This is a road upright that's hollow, and it's got holes. The blue arrow is the direction of the water flow. Essentially, there's nothing there. Curb inlet guard. Everybody's using these. This is where I say, read the fine print. You have to use gravel bags. It specifically states no sand. It does not give you a space beyond the catch basin that you have to protect, but you need to put it far enough on either side. Maybe a good rule of thumb might be 4 to 5 inches, so that when a car hits it and moves it slightly, your drain is still protected. This one, from my standpoint, is difficult to see, but they did not put a gravel bag over that overlap where the arrow is. So any water coming down is going to go behind it and into the drain. Excuse me. On the right, that's 3 sections. They put the section in the middle behind the other 2, and they ought to use 1 snake bag. So think about how you're installing these things. You might save on the cost of an extra snake bag. Now this is up here again because of the installation of it. Now if you just have this sheet in and you look at that, you're going to say, oh, I just need to put it to the catch basin opening. The answer is no. This is part of the installation instructions that's given by the distributor here on Oahu. Notice it goes beyond and it's wedged back into the thing. The one on the left is properly installed. The one in the middle looks like it's good, But here's what it is on the other side. It did not bend back in, it was not wedged. Directional channels prevent a challenge because most of our BMPs will sit on top of those and you end up with pukas underneath. This was one way they solved it. They stuffed some fabric under there. Whatever you use needs to conform so that you don't have the pukas underneath. BMP inspections. It's not just the guy that does the BMPs. It's everybody's responsibility on the site, from the laborer to the equipment operator to the foreman to the inspector to the engineer. Before any operation, somebody needs to run around and look to make sure BMPs are in place. Anybody sees that they're not should stop the operation until they're fixed. In this particular case, you'll see a shiny area just in front of the concrete gutter. That's tack coat. This inlet was open. It had been opened. All those people on site never noticed that, and luckily they had a good tack coat operator. He didn't get anything on the concrete. If it had sprayed in there, it rained and it broke and ran into the inlet, they would have had a critical deficiency. So what happened? They called the guy in charge of BMPs that was off someplace else. Instead of just going, sliding it, and repositioning some snake bags. Construction entrances. Rock is supposed to be 3 to 6 inches. If you're doing state and city projects, the city now runs 3 to 6 inches. They used to run 1 to 3. But since 2011, it's 3 to 6. I had one contractor that told me they called up a distributor and said, we need rock for construction entrance. And the guy said, oh, well, you know just what you need, and sent out 1 to 3. Then I come along and tell them this rock's too small. There are commercial alternatives, and I'll show you 2 that are currently being used on Oahu. And if you don't put in a construction entrance, you still need to provide some sort of mechanism so you don't track on the roadway. Rock too small, rock the correct size. So to correct the deficiency, it costs the contractor more money. So order the right rock when, specify what rock you want. These are 2 alternatives that are currently being used here on Oahu. One is Geotero GTO mats. If you're down around University, they're being used at that site, also at Kuopani. The one on the right is Eterno mats. That's up at Cam 4 in Leaky Leaky. I'm curious to see how these things hold up in the mud. Right now, there's no problem. If you're doing a paving project and you're parking your equipment off on the shoulder, make sure you have a mechanism to get them to the road without tracking. The one on the left actually has a construction entrance. On the right, they don't. And it was a night paving project, so every time the maintenance guy came in to maintain in this wet area, they had mud going down the road. Hazardous material, I'm going to hit on labeling. Per OSHA 1910, they must be stored in labeled containers. All containers have to be labeled. And this became effective under the new global harmonizing system. The date was last year, 2015. If you put it in you have to provide secondary containment, appropriate size containment. It needs to If somebody punctures one of your drums, it needs to be able to hold the product away from surface waters. Metal containers, either angled or covered to prevent ponding on top because they will rust. If you're putting a product into another container, it must be labeled. And that doesn't mean writing on it with a Sharpie pen. It means labeled. The only exception is if you send the guy that's going to spray the concrete cure over, if he pulls it out of the drum, puts it in the sprayer, and goes and uses that, that's okay. These are two examples of problems we had recently. The one left had the product name, Flexilift Ready Pack 3-part unit. Okay, what is it? Nobody could tell me when I was out there. Looking it up, find out it's a sealant for roadways. And according to the SDS sheets, Flexilift was either, depending on the component, was a mild irritant, or it could cause cancer, or it was toxic to aquatic life. On the right, the only indication of what was in these containers was somebody wrote on the lid in a Sharpie pen, retarder. When they went into the Flexilift, they found out why it was a 3-part unit. There are 3 parts in it, and each one had a proper label. What this particular contractor did was slap some pictographs on the exterior container so you could tell that it was hazardous, and they moved it to their storage area. Because unless there's something indicating on the outside of a sealed container, you don't know whether you get what's going on with this product. If you're bringing a barrel of concrete cure out to a site to be used, put it in secondary containment. You can throw it in a kiddie pool, something. This is what you can end up with if you don't have secondary containment under it. Concrete cure all over the ground. It was nicely covered. Do not be surprised if somebody unwraps something to check containment underneath your product. I've shown these before, just some examples of bad stuff. Self-rising float doesn't work when you set something on top of it. On the right, I have no clue what was in that rusted out container. There was goop in there, but the label had washed off. Make sure it sits on the pallet. If you're going to create your own, make sure it's sturdy enough so that if you move stuff around, it stays in place. These are 2 examples of good containment. The metal drums are covered by the viaduct, and there is a berm at the front, so if one of those gets punctured, it will stay in place. There's plastic under that fabric. Coal patch and waste asphalt is considered hazardous. It's a petroleum product. It needs to be not on bare ground, needs to be set on an impervious layer covered with perimeter control. On the left, this should have been planned out to have a site prepared for when the operator came and dumped the load. On the right, all it takes is a shovel to clean it up. All the SWIPs now have a thing about construction material. This is out of Appendix C. In the SWIP, it lists rebar and galvanized steel pipes. These become point source for pollution. Matt Carano has stated in some of his past briefings, he's looking at rebar. Rack it and cover it. If you're lucky enough to be near the viaduct, you can store it under the viaduct. This is contaminated soil on the left, lead contaminated. They have a concrete pad that they're putting it on. It's in super sacks and it's covered till they can dispose of it. We're finding a lot of railroad ties on some of these projects these days. Those are creosote soaked. They again need to be off the ground or not come in contact with rainwater till they're disposed of. Porta potties. Appendix C says secured from tipping over. You also should not put these things right by a drain. This kicks in a whole new set of problems with sanitary or sewage spills. On the right, that was actually blown over. Luckily, they had serviced it. It had a trap in it. It fell on its back, so we could open it up and found that nothing spilled. Two examples of ways people have secured them. If you're lucky enough to have a puka in the skid underneath, you can just put a forming stake down through it. They screwed or nailed it to the wooden skids. On the right, they tied it down. Drip protection. You got pans, absorbent tight, all have one thing in common, prevent from leaching to the ground or off the site. On the left, this is an example of pans with depth. The reason I use this picture is because it's a large project. They have pre-positioned drip pans and spill kits throughout the project. So if an operator needs to leave his equipment in the site, he doesn't have far to walk to get the drip pan. On the right, these are, I call them cookie sheets. They are drip pans. They're best used in warehouse situations. But if you're using them on a site, you need to make sure they're extremely level because there's very little lip, so they don't take much rainwater either, and they're light. And they only survive one run over. Also, again, two common types. Roll out the fabric over the plastic, and the plastic should be the same size, if not larger than the fabric. On the right, they have created a scroll with absorbent, barrier material. Roll it up, put it on the equipment so it can go with the operator to wherever that piece of equipment is. It doesn't stipulate in the BMP manuals, it just says paving equipment will have drip protection. You need to put it under the hopper and the roller assembly. And trust me, you can't get a drip pan under there. They don't make them big enough. So you need to resort to the fabric and the plastic. If you do not have it and it rains, this is what you end up with. You end up with an oil slick out the back of the paver. The day that picture was taken, it had been bone dry all day. On the right, they had the barrier material, they had the steel plate, nothing to absorb the leak from running off the steel plate onto the ground. This is why the plastic needs to be the same size, is not bigger. Remember, this fabric is the same stuff a lot of people put in the drains. It filters. Very little absorbent properties. Once it's saturated, it soaks through. Your distributor trucks, I can always tell where it's parked because there's a line. That's a good candidate for that little scroll type thing that you can put on the truck, so when he parks in the grass, he can roll that out under the spray wand at the back, so I don't find the line. Concrete waste management. Wet concrete on the ground is a no-no, unless it's where it's supposed to be. It needs to be picked up while it's wet and disposed of in a washout. Kiddie pools usually only survive one use because concrete is caustic. It has a pH of 12, Drano 13.5. They become brittle and they end up with pukas. I also recommend a lot of times that you put plastic, burned plastic, under your concrete washout in case they spring a leak, and that's a contractor constructed washout bin that actually had 3 sheets of plastic in it. Make sure you have enough freeboard. They're only supposed to be filled 75%. Notice the waste concrete overflow. Don't listen to the boom truck operator say, oh yeah, I just got a little more, I got a little more, because it'll get you in trouble. Now what they did do was put a piece of rebar in it so that it's easy to pick when it dried. On the right, if you're doing an in-ground washout, it needs to be lined with 1 sheet of continuous plastic, not overlap plastic, continuous. If you overlap the plastic, the water's just going to run in between the overlap. And when I say 1 sheet, I also mean it's good to have multiple layers, but Erosion and sediment control. Got to prevent it from leaving the site. You're responsible for what happens beyond the project limit. I go out there and I say, what about the drain 25 feet down? Well, it's outside our project limit. Well, you know, you need to put protection in there. This is an example of filter socks and snake bags being used per manufacturer's instructions, but it's not good for this site. It's a very unstable hillside. It just comes down and you can see the pile of gravel underneath. Either stacked and staked socks, and there is a method to do that, located in manufacturer's instructions, or choose a better alternative would have been silt fence. Here's the case, and I won't go into why it's only mostly good. It's a similar situation, very unstable hillside. They use 2 layers of silt fence. Now, if you use 2 layers, you need to make sure they're positioned far enough apart so when the first one fails, it doesn't take out the second one. This is an example of, again, filter socks used per manufacturer's instructions and installed per instructions. Keep in mind, these are mulch. They are not compost. Even the compost will float. These things will float during the initial rain. Until they become saturated, they will raise up and the water will go underneath it. And then you're liable for that runoff. In this case, it eroded under the velocity dissipation device or the mid-slope, and it pushed out the ones at the bottom. Also, I ought to point out, if you're doing a slope project and the slope is over 15 feet, per section 209 of the 2005 DOT specifications, you are required to have velocity dissipation devices on that slope. In terms of vegetation, you must either stabilize the area either through vegetative or non-vegetative means. If you do not have a dedicated water source, that presents a challenge, not an excuse. You can use a water truck. This is an example. This was 2 areas side by side. One had been hydromulched 3 to 4 weeks before, the other hadn't. The slope on these things was also very similar to the one you see on the right. Same storm washed out the silt fence. There is a method to roughen the slope. There's one project out here that did that. You provide recesses where the water and the seed will stay a little bit longer. In the front wasn't very roughened up, but this is about 2 weeks growth. Here's a closer image of what occurred out there. That's 2 weeks of growth. They did have sprinklers, by the way. Erosion control matting. Per our manual, top and bottom anchorages. Most of the manufacturer's instructions will show you a top anchorage, and then they just, in the picture, it just runs out. And it tells you to consult your local expert or your landscaper for the bottom anchorage. Without something specific about the bottom anchorage, this is what kicks in. You can also put in intermittent slopes. This takes some planning, because a lot of landscapers like to make it nice and neat, and they will trim it, top and bottom. Here's an example of that anchorage going in. In the center strip, it's backfilled. Now they're going to flip it over. Repairs. Everybody knows I'm death on duct tape on biosocks, because they always constrict it and leave a puka underneath. Don't wrap it in plastic, it doesn't filter. And if I cite you for having used duct tape and I come back out and there's fabric in that area, don't be surprised if I go down and do a touchy-feely. You need to take the duct tape off. Here's some examples of fabric wrapped. It needs to go beyond the rip, and it needs to be overlapped around the biosock sufficiently so it doesn't spring open like it does on the right. Here's two examples of other methods, using zip ties to close up a small puka. This contractor was able to get a hold of the biosock fabric, and what they did is they slipped it over the tear and then tied it beyond that. So if you cannot get a hold of it through the distributors, and I'm told at least one distributor has tried to get it and has been unable to, if you've got some biosocks that you're retiring and you have the time and the personnel, you might want to take the fabric off and use it. It makes it a lot easier. Okay, in summary, carefully consider what you're putting in your SWIP. It's a living document. Now, when you get the bid package, a lot of times you have a sample BMP plan that the designers did. That is a starting point. That doesn't tell you what you have to put in, it's to give you an idea of where you need to head. So if I say, well, that's not quite good enough, it doesn't mean you go back to the designer. They're done with the project. You need to make the SWIP your own. It's the responsibility of the contractor in DOT to have an effective SWIP, not the designer. You need to make sure you read all your permits carefully. Sometimes they contain some specific things that you have to do for your project. Maintenance is a day-to-day thing. It is not something you wait for an inspection to come across. You know, a lot of times when I go out and inspect and there's like a 3-day weekend or a holiday, they say, well, can't you slip that 5 calendar days? I say, well, no. It's dictated to me, it's 5 calendar days. I'm finding this stuff, if DOT found it on the project, most of the time, the rules there under the ERP say you correct it that day or the next day. So, hey, now you got 5 days. You need to install BMPs per plan per manufacturer's inspection. Inspect the unexpected. I can't tell you how many times that somebody has got a hillside and all of a sudden they find a spring and they're flooding and they got this big pond that they got to deal with. Or they put in straw wattles, this is on the Big Island, put it close to the fence, the next morning they come back and find the horses having a snack with a straw wattle on top of the fence. That one was a new one. You got to keep your sense of humor. If you don't, you're going to end up being really cranky out there. You know, find the humor in something. Enjoy the process, even though you're getting inspected and inspected and inspected. So, are there any questions?